I should write down a problem. That's, yeah, whoops. There we go. I wrote these in 3 different colors just to hopefully keep it more organized, and so you know which piece is going where. And we're going to solve this 3x3 system, which means these are planes in 3D space. We're going to solve this using elimination. So the first step, and I think I'll write down all these steps afterwards, just so you have a template. For the first step, all you have to do is choose 2 equations and eliminate 1 variable, just like we did before. So let's see what we can do. It really doesn't matter which 2 equations I choose first, because I'm going to choose 2, and then I'm going to choose a different 2 afterwards. So I think for the first part, I'm just going to choose the first 2 equations. So I'll write those on the side. I do it on the side. So that's the first thing I'm going to do, is just choose 2 equations. So that goes there. And then the next thing I'm going to do, before I even do anything with this, before I even do anything with that, is I'm going to choose 2 different equations. I could choose those 2, or I could choose those 2. It doesn't matter. And in this case, I think I'll just choose the green and the red. So I've chosen, the only thing I can't do is choose like the same equations here and the same equations there, 2 of the same. I know that this green one is repeating, but that's okay. As long as I have something and then green, that's fine. And green and then something else. I can't have these 2 being the same. Okay, so then what's next? The next step is to eliminate, we got to pay attention and be careful that we copy everything down correctly. But we have to eliminate a variable. So I'm going to go on this left side and think to myself, which one's an easy variable to eliminate? I think this would be easy, because I could just multiply this equation by 4, and then I would have the same number but opposite signs. So that would be easy to eliminate. But here's the thing. Whatever variable I eliminate here, I have to eliminate here as well. Is y easy to eliminate here? Yes, it is. I can multiply this equation by 2, and then I would get -2 here and a +2, and then I could eliminate that. So we gotta eliminate the same variable. So that's super, super important. And I'm gonna choose the y's because it's easy to eliminate. So I'll work in blue for my work. And what do I have to multiply this by? +4, and I have to distribute it all the way through. So I'll rewrite one of my equations, the black one. I'll rewrite that, and then I'll rewrite the green one after I distribute. So this would be 4 times 2 is 8x. 8x. 4 times -y is -4y. That's distributing there. And then 4 times 2z, that's 8z. And 4 times -7, that's -28, I think. So there we go. I'm ready to eliminate. So I'll add these together. This is just the same as the 2x2 equations, where I only have an x and a y. So like same steps, except for I have to just distribute to an extra thing. That's all. That's the only thing that's different. So I'll add these together, and I get, this is a 1x. And my new equation, I'm going to write in blue. So add those together, I get 9x. Add those together, and they cancel out. Add these together, what do I get? 8 plus a -6, or -6 plus 8, that's +2. And it's z. And then add those together, it looks like 29, -29. Did I copy that down right? Okay, cool. And then I'm going to do eliminate the same variable in the other, the other 2 equations. So I must eliminate the y. Dang it, I keep doing that. There we go. Eliminate the y's. So that means I would have to multiply the top equation by +2. Because once I do that, this becomes a -2y, and it'll cancel out with that. So there I go. I'll copy down my red equation and then write down my new green equation. So in my green equation, when I multiply, when I distribute through, well, first I'll get 4 x, then I'll get negative 2y, and then I'll get positive 4z. Ooh, look at that. That cancels out as well. I wonder if that'll cause a problem. 2 times the negative 7 is negative 14. Okay. And then what do I do here? Okay, so now I will add these two together. And what do I get? So I'm adding the x's don't cancel out. That would just become, I'm going to write it in blue, 3x. The y's cancel out. And look at that. The z's actually cancel out as well. Is that true? Looks like it. Yes, the z's cancel out as well. Okay, I guess that's what happens. And then negative 14 plus 5, what is that? Negative 9. So I'm ready to use these two equations. I'm definitely going to do another example where this doesn't happen, but I'll use these two equations. The normal steps would be to use these two equations with each other. So I would have this and that, and I could do it by elimination still. But here's the thing. This is already, like, I can solve for x. Once I solve for x, I could plug it in here and solve for z. Once I solve for z, I can plug it into any one of my originals and get my y, my third variable. So here, I think what I'll do is I will solve this one because I can. It only has a single x. I can solve that. So I'll take that over to the side and solve it. So if I solve this, then I divide by 3, and I get x equals, and I'll write all my answers in black, x equals negative 3. It's important that you get that negative. There's plenty of places to mess up with this, so we're going to practice a lot. So I have my x, and now I plug it into a two-variable equation, which is this one. So if I plug this into there, what will I get? I get 9 times negative 3, and then plus 2z. Plus 2z equals negative 29. And I'll solve for z. So I already have x. So that's my first I guess ordered triple. It's my first entry in my ordered triple. So negative 3. I'll have a y and then a z. So some people might be unfamiliar with this. X goes first, y goes next, z is just alphabetical order, z goes last. Okay, so if I solve for z in this equation, then what would I get? I would get negative 27 plus 2z equals negative 29. I'll add 27 to both sides. I'm just solving an equation. Just solving an equation, just like normal. And then I get negative 2. And then I can divide by 2. Oh, that's pretty nice. And then I get z equals, it's just negative 1. Okay, maybe I should write that in black. So now I have two of my variables, and now I need the third. So the last step. Oh, this is. We're not going to have like so many problems for homework, but we are going to have some problems. So what next? I have to plug it all back in, just like with the 2x2s. I plug it into an original equation. Same with this, except for now I have two things to plug in. So let's pick one that has the smallest numbers. It actually doesn't really matter. They're all almost the same. I guess I'll plug it into the top one. Actually, wait, I'm solving for a y, correct? Yeah. I'll plug it into the top one. X plus 4y minus 6z equals negative 1. So the top one was black. X minus, I can't even remember, plus 4y minus 6z plus 4y minus 6z equals negative 1. So I'm using that, x plus 4y minus 6z equals negative 1. X plus 4y minus 6z equals negative 1. It's so easy to copy these things down wrong, so you got to be careful with that. And then instead of writing x, I'll write negative 3. Instead of writing y, I'll write negative 1. And then I'll see what I get. So I have a negative 3 plus 4 times y. I don't know what y is, but I'll solve for it. Minus 6 times negative 1 equals negative 1. All right, let's do this. That's just negative 3 still. Negative 3 plus 4y plus 6 equals negative 1. I can combine like terms. 6 minus 3 is 3 plus 4y equals negative 1. I'm just solving for y. This should be easy. Minus 3, that goes away. 4y equals negative 4. Divide by 4. Whew! That's ridiculous. That's so much work. Y equals negative 1. If you understand how to solve these, then you can like write a computer program to solve it for you. That'd be cool. And then that would be negative 1. Alright, so this is my answer. This is the point in 3D space where all of these planes intersect. Oh my goodness. That's crazy. So really, it's a task at being organized. And this is not even that organized, but the colors hopefully should help. Let's see. This video's too long. I'm going to stop it. I'll just say the steps. First, you choose 2 equations, and then you choose another 2 equations, and you eliminate the same variable. And for us, it turned out that we eliminated 2 variables at once, so we could solve for x. Plug it into the 2 variable equation, solve for the other variable, and then get those 2 variables and plug it into any of the originals and solve for that 3rd variable. Okay, I'm done with this.